Hello students, I Vivek Thadani welcome you all in the Brilliant Public School YouTube channel. Today we will discuss about chapter 2 Polynomials, class 9th Mathematics. Polynomials, we very well know, they are the algebraic expressions written in one variable. Algebraic expressions are made up of constant, variables and the arithmetic operation. But when we represent polynomial, they look something like this, which you have already seen. Px is equal to x plus 5. This is the way we represent a polynomial. I can give you one more example that could be x square plus 2x plus 3. So this is the way we represent polynomials. There are some terminologies that we generally use in polynomial. The very first one is terms. So if I talk about x plus 5 being a polynomial, there are two terms which is x and 5. So their terms are being separated with a plus or a minus sign. Next, what you will see is coefficient. So if I talk about this polynomial 3x plus 5, for 3x there is a numerical coefficient 3. But we need to understand that we will have so many coefficients for each and every term. Then there are constants. So constants are basically the polynomials where no variable is present. For example, if I will give you 5, 5 is a constant polynomial, but we understand 5 can be written as 5 into 1 and that can be written as 5 into x to the power 0 because we very well know value of x to the power 0 is equal to 1. So in this manner, in all the constant terms, there is a hidden x whose power is 0. Then there will be one more term that we frequently use is the degree. And degree is the highest power of the variable. Again, I am telling you highest power of the variable which is known as degree of the polynomial. There are some important things for you, which is degree of a constant polynomial is 0, as just now I have explained you. But if I talk about degree of a 0 polynomial, that is not at all defined because we will multiply any number. Any number will be multiplied with 0 that will result as a 0 only. So that is the thing. Degree of a constant polynomial is 0, whereas degree of a 0 polynomial is not defined. Moving on to the types of polynomials. If we talk about types of polynomials, there are two categories on the basis of terms and on the basis of degree. So this we have already studied. One term that means monomial, two terms binomial, three terms trinomial, and when there are four or more terms we consider them as polynomials. Also, on the basis of degree, right now we have discussed when the degree is 0, it is constant. When the degree is 1, it is a linear polynomial. Degree is 2, it is a quadratic polynomial. And when finally the degree is 3, it is our cubic polynomial. Then one of the important topic is there which is 0 of the polynomial. You can read the definition. 0 of the polynomial is obtained by equating the polynomial with 0. So you can understand if I will consider this polynomial and I will take it equals to 0. So x plus 5 equals to 0. If I will transpose 5 to that side, no doubt I am going to get x is equal to minus 5. And obviously, this is the 0 of the polynomial, which is also known as the root of the polynomial. Because if I will substitute this minus 5 in the given polynomial, no doubt I am going to get a 0. So let's check that if I will put p minus 5 in place of x. So minus 5 plus 5. No doubt the polynomial will become 0. So here x is equal to minus 5 is the 0 or the root of the polynomial. Then we have one more important thing in this, which is our factor theorem. Factor theorem, like suppose if I'll give you an example, px I have to divide by this gx. So the thing goes in this manner, we always find 0 of the gx, 0 of the divisor. So if I talk about this expression, x plus 1 I will take equal to 0 and value of x will be minus 1. If minus 1 I will substitute in this px, there will be two possibilities that after substituting I can get a 0 or I will get a non-zero number. So the condition is if I will get a 0, the gx will be considered as the factor of px. When the remainder, when p minus 1 will give you 0 and when it will give you a non-zero value, that time it is very simple, gx is not a factor of px. So in this we understand that if the remainder is 0 or non-zero, we can talk about the factor or not a factor. Then at last in exercise 2.5 you will see we have algebraic identities. So these are few identities which you are going to use in the exercise. Identities, if I talk about this, a plus b whole square, and we very well know it is equal to a square plus 2ab plus b square. Only thing I want to tell you that if I will go from LHS to RHS, I am trying to find out the product, and that helps me a lot when I do some calculation. Also, I want to explain that if I will go from RHS to LHS, that time I am working as a factorize. I am trying to factorize this given expression a square plus 2ab plus b square into a simplest form into smaller brackets. So that time I am just working with the factorization. I hope you understood all the concepts. Thank you so much.